Hey everyone, so today we're going to be graphing systems of linear inequalities. Basically what we're going to do is take the skills that we learned about graphing linear inequalities and just graph two on the same graph. So let's get started. So a system of linear inequalities is going to look like this to some extent, where we have one inequality graphed and shaded, another inequality graphed and shaded, and then we're going to see they overlap here. So a system of linear inequalities is a collection of two or more linear inequalities. The solution to a system of linear inequalities is where the shaded regions overlap. This is called the double shaded region. A solution cannot fall on a dotted line. Okay, and you can see here in this double shaded region, we have an S here because that represents the double shaded region. That is the solution. So, for example, say we wanted to identify some solutions to this system. So it has to be in this double shaded region. So for example, this would be a solution, this point here would be a solution. It's still in the double shaded region. This point here would be, it's still in the double shaded region and it's on a solid line. So these are all scenarios where we would have solutions. Now, obviously, this would not be a solution. It's not in any shaded region. This would not be a solution because it's only in one shaded region. It's not in the double shaded region. Same with a point down here, a point over here. These are not solutions because they're not in the double shaded region. And then this one would probably be the hardest one to identify. But remember from yesterday, if it falls on a dotted line, it is not a solution. So this is not a solution. It has to either be in the double shaded region or it has to be on a solid line in the double shaded region. Okay, so we're going to practice graphing these. We have y is less than 1/2 x minus 3 and y is greater than or equal to negative 3x plus 4. So first step is translate into y equals mx plus b form if needed. So here our y's are isolated, so we don't need to do that. The next step is to graph the first inequality and shade in one direction. So let's do this first one. And I'm going to do this one in red. So here we have our slope. So I'm going to just say this is what m is equal to. And our y-intercept is negative 3. So we're going to start at our y-intercept of negative 3. And then we're going to go up 1 to the right 2. And I'm going to do that until I cannot do it anymore. As many points, we want to go from one end to the other end. Very, very important with linear inequalities. Okay, before I connect these, I want to identify if it's going to be a dashed or a solid line. This tells us here our inequality symbol is a less than sign, so that tells us it's going to be a dashed line. So I'm going to just connect these with a dashed line. Okay, so now I also want to do the shading before I graph the other line. So we're going to pick a test point. So I'm going to pick the test point 0, 0. So 0, 0. And I'm going to plug those values into our linear inequality. So we have 0 is less than 1/2 times 0 minus 3. All I did was take these values and plug them in for x and y. So we multiply here, we get 0. Bring everything else down. Subtract here, we get negative 3. So is 0 less than negative 3? So think about it, is 0 smaller than negative 3? This is false. So remember, if it's false, you're going to shade the side of the line that doesn't contain the test point. So if the test point is up here, it's on this side of the line, and it's false, that means we're going to shade the other side down here. So this one I'm shading up and down. Okay. So now I'm going to graph the second one. I'm going to do that one in red. I said I was going to do the first one, but I'm going to do this one in red. So this is my slope. It's really negative 3 over 1. This is my y-intercept. So the next step here is to graph the second inequality and shade in the opposite direction. So we're going to start at our y-intercept, which is positive 4. And then our slope is negative 3 over 1. So we're going to go down 3 over 1 and continue that for as long as we need to. Okay, there's our point of intersection. It's always a good sign. Okay, now dashed our solid line. This is telling us because it's greater than or equal to that it's going to be a solid line. So we can just connect these points with a solid line. And I'm going to pick the same test point, 0, 0. So I'm going to see if I'm going to shade to the left or to the right of this line. So 0, 0, we're going to plug that in. So we get 0 is greater than or equal to. Careful with your sign, a little smaller. 0 is greater than or equal to negative 3 times 0 plus 4. Multiply here, we get 0 plus 4. That's why I love to use 0 here. Add these, we get 4. So now we need to decide if this is true. Is 0 greater than or equal to 4? So is 0 larger than 4? Because remember, alligator eats the bigger number. Is this true? No. We know that 0 is smaller than 4. So this is also false. So we're going to shade the side of the line that does not contain this test point. So the test point was on this side, so we're going to shade the opposite side, which is over here. And I'm going to do this horizontally because I did the first one vertically. Okay, and notice I'm going all the way up and down. We're not leaving anything out. Okay, when you go in different directions, it gives you a better idea of where they overlap. So when we identify where they overlap, we're going to put an S in that double shaded region. So here I'm going to put a big S because that is our solution. Sometimes they'll ask you to put an A for answer or an S for solution. Just make sure you read carefully. So what we did was we graphed the first inequality. We made sure that we identified if it was a solid or a dashed line, and then used a test point for shading. We did the same thing with the second inequality. This one was a solid line. We used the same test point, and then we just put an S at our double shaded region. So now we're going to take a look at an example like this, but on Delta Math. Okay, so here we have a question that says, solve the following systems of inequalities graphically on the set of axes below. State the coordinate of a point in the solution set. So remember, a point to a system of inequalities has to be in the double shaded region, cannot fall on a dotted line. Any other point in that fit that criteria will work. Okay, so let's get started graphing this first inequality. I'm going to do this one in red. Y is greater than or equal to 3x minus 5. Our slope is 3, so that's 3 over 1. Because remember, we want to make all of our whole numbers into fractions so we can see the rise and the run, and then that's going to be our y-intercept. It's a positive slope, so that means we're going to be going up and over, starting at our y-intercept of negative 5. If you're still struggling with this, please make sure you practice just graphing lines. You need the slope and the y-intercept. There's videos, there's all different kinds of resources you can find on our Google Classroom. Okay, so I put my point at negative 5. I'm going to go up 3 over 1. Now I need to decide if I'm going to change this line. I see here that this is greater than or equal to. So that means that this is going to be a solid line, so I don't have to change this into a dotted line. I'm going to leave it solid. So now I need to know where I'm going to shade. I'm going to pick my test point. You guys know my favorite test point is 0, 0. Let me just make that a little more. Okay, 0, 0. So I'm going to take this x value and this y value and plug them into the inequality. So we get 0 is greater than or equal to 3 times 0 minus 5. So all I did was substitute 0 in for x and for y. Multiply here, we get 0. Bring everything else down. Subtract here, you get negative 5. So this says 0 is greater than or equal to -5. Now we have to decide if this is true or false. 0 is greater than all negative numbers, so this is true. So we are going to shade the side that contains this point. So we're going to shade this side of the line because that's where the 0, 0 is. So let me change the shade. So that is the side that doesn't have 0, 0. We want to shade the side that does have 0, 0, which is going to be right here. Okay. So now we're going to graph the second line. So I'm going to just erase this so we have enough room, but I'm going to do the same thing. We're going to graph this and we're going to plug in our test point 0, 0, as long as 0, 0 does not fall on the line. So we'll take a look. So I'm going to clear the screen and we're going to do this one in blue. So y is less than -x minus 1. Remember, if there's no number in front of the x, it has that little invisible 1. So our slope here is -1. I'm going to put that over 1. And our y-intercept is also -1. Okay, so we're going to start at -1. On our y-axis, go down 1 to the right 1. So I'm going to go to my graph, start where y is -1. I'm going to go down 1 to the right 1. Okay, so our line is graphed. Now we want to decide if we want to change our line. Also, just in case you realize you made a mistake, you can always go back to line 1 and you can change whatever you need to change here. But if we're graphing line 2, make sure you're on line 2 on Delta Math. Okay, so let's take a look at our inequality symbol. Here we have a less than symbol. Now remember, if it's not less than or equal to, if it doesn't have that or equal to part of it, it needs to be a dotted line. Dotted, dashed, whatever you want to call it, it cannot be a solid line. So we do want to change this line. So I'm going to go ahead and do that. And now we can see that it's a dashed line. And now let's decide where we're going to shade. So 0, 0 is very close to this line, but it's not on it. And I can see that it's on this side of the line. So I'm still going to go ahead with that test point. 0 is just a really easy number to work with. That's why I like this point. Okay, so I'm going to plug these values in for x and y. 0 is less than -1 times 0 minus 1. Multiply this, you get 0. Bring everything else down. 0 is less than 0 minus 1 is -1. So now let's identify if this is going to be true or false. 0 is less than -1. Is that true? No, this is false. 0 is greater than -1. So in order for this to be true, this symbol would have had to flip. So this is false. So we are going to shade. So I'm going to put an X there for this is wrong. So we are going to shade the side of the line that does not contain this test point for the second line. So I'm going to go back here and we're going to change the shading. I'm going to just move this up so it's out of the way. So we can see here that this shading contains the point 0, 0, but we don't want that because it was false. We want to shade the opposite side. So it should be shading the other side of this dotted line. Okay, so now that we have our shading done and we graphed everything, now we need to pick a point in this solution set. So, like I said, I'm going to just erase this over here. Like we talked about before, it can be any point in the double shaded region as long as it does not fall on a dotted line. It can fall on a solid line, but I wouldn't even go for a point on any line. Just pick one that's in this double shaded region. So I'm going to go with this point here. Oops, sorry about that. So I'm going to go with this point here. I'm actually going to draw that so you know exactly which point I'm going for. I'm going to do it in yellow so you can see it. -6, -3. That's the point I'm going to go for because it's in that double shaded region. But you can pick any point. It does not need to be this point necessarily. It could be any point in the double shaded region. When you do that, make sure you click submit. Am I sure? I'm pretty sure. Sometimes you make mistakes, but this was right. Okay, so graph the first inequality in shade, then graph the second inequality in shade. Make sure you pay attention to if it's going to be dash or solid. Make sure you pick the correct test points, and then any point in the double shaded region is a solution. So you can see here, their sample point was -9, -10, because it's down here, it's in that double shaded region. Okay, good luck.